My name is David Taylor and I'm the u-blox product manager here at Alpha Micro. Thank you very much for joining us today. So today I'm going to focus on three of u-blox's exciting and new low power wide area or LPWA modules that cover the LTE, Cat-M or NB-IoT or 2G cellular technologies. First though, Alpha Micro have been a specialist embedded wireless modules distributor since 1995, so we're now in our 26th year. Of that, we've held the u-blox franchise for over 14 years, and during that time we've seen huge changes in the cellular and GNSS space. Many on the webinar already know of us, but for those who don't, we've built up a huge knowledge base which is shared among our u-blox trained engineering team and backed up by a technically biased sales team, all offering many man-years of knowledge and experience in the products that we supply. We provide this free of charge support to our customers. This support is one of the cornerstones of how we've added value to our customers over the years by helping them get up and running during the product development cycle and into production. So the breadth of our support doesn't just go to assisting customers with AT command configurations. We'll offer free of charge design reviews, all as part of our customer support service. So typical in electronic component design is integration, integration, integration. And wireless modules are no exception as to the drive to make them smaller, lower powered, and of course, lower cost. The level of integration, more features are added over previous generations, which I'll show you more in subsequent slides. Another large concern to customers, as well as the integration, is the security of devices. And by this, we don't necessarily just mean security of data between devices and the cloud, but a better integrity of the product as a whole. So some examples of target markets. Here are some popular use cases of IoT low power applications. In animal tracking, the overall size, including battery, has to be small. The antenna is often compromised, so the RF performance and overall communication message sent needs to be optimized. In asset tracking, it often has a covert antenna, again in non-ideal environments. We've had first-hand experience of this in working with customers who have developed asset tracking projects, most notably in parcel tracking applications. And some of the challenges they have are with GPS or GNSS. They cannot see the sky. How do they maintain a decent quality of service? How do they monitor movement, all whilst maintaining very low power? We've got products that meet these requirements now and are being deployed in volume with the confidence that when the next generation product is released, they can drop down onto their board and take advantage of the new features. In connected health, devices need to be compliant for use near to the human body, RF efficient, and protect patient privacy. Especially of importance in this sector, tend to require a long product life due to a more complex and lengthy approvals process. In our opinion, designers have three options when building. I've moved ahead a slide, I do apologise. So there's three main options when building an IoT low power product. And this session is going to address the standard and system in package options, or SIP. Our modules are based around a long-term availability of integrated chipset platforms, which offer seamless operation with u-blox GNSS, Wi-Fi or Bluetooth modules, along with the flexibility to choose the best suited module for specific applications. The chip down designs, especially in the cellular space, cost upwards of £1 million in development, licensing, approvals, and then the ongoing keeping the product afloat. So unless volumes are designing for consumer electronics in hundreds of thousands or millions, and there is a significant R&D budget, most of the UK customer base tends to avoid this route As current u-blox users will already know, u-blox have adopted a common form factor across their various modules, and so this can be mounted onto the same board space. This provides an optimal solution for cost, size and wireless technology, and allows for a simple migration between technologies and module generations. Not only are modules footprint compatible, but they're also pin and electrically compatible in most cases. Additionally, there's an AT command compatibility between modules. To denote the variants of modules, u-blox have named them according to their footprint size. For instance, the SARA range, which we'll talk about later, measures 16 by 26 millimeters and comprises of over 15 different technology variants. These cover 2G, 3G and a low speed LTE in the common 16 by 26 millimeter form factor. Lara and Toby modules are also depicted in this slide, and they're featured in this nested form factor, so they can be similarly laid down, and the modules offer over the higher over-the-air data rates. As a quick look at the technology comparison, we've produced a matrix here. So with low power wide area comms, as well as the u-blox standards-based technology modules, which we'll come on to, there are other shows in town relating to this technology, namely Sigfox and LoRa. What we feel on the u-blox modules, though, is they do offer that global range of frequencies and a licensed spectrum, which offers a guaranteed quality of service. So that can be important if you're really scaling up, either through Europe or globally. 2G is mature, but has an excellent coverage still, especially in the UK. And we do have products which have adopted 2G as well as LTE-M and NB-IoT into the same product. So how to select the right product? To use the selection chart, first and foremost, you'll need to determine whether 2G fallback is an option. Advantages are that you'll use a legacy, widely adopted technology, which has been in operation since the early 90s, so it's around 30 years old. However, we believe it's going to be considered to be withdrawn in this country in around 2025, so about 4 years' time. Disadvantages are for low power applications. 2G is considered power hungry in relation to Cat-M and NB-IoT. It has a 2 amp peak power, so you have to gear your power supply for that requirement. And therefore the overall power budget and your life in the field could be restricted as a result. Then you follow the flow chart down based on your eventual criteria for your product. Here's a typical u-blox roadmap slide, and this is relevant to Cat-M NB-IoT based modules. You'll see on the left-hand side the SARA R412 and the 410 and the R510 range. So they're all in production and shipping now. The SARA R412 and R410 have been in production for about 3 years. So we've already got lots of experience and use cases which we can help you with. Both of these are based around the Qualcomm 9206 chip. You'll see top right are the new SARA R422 range, which are based on the new Qualcomm chip 9205 and will be going into production in a couple of months' time in May. The bottom half of this slide shows the SARA and a new footprint called the Alex, which are both based on a u-blox LTE chipset, which was released last year. The SARA R5 went into production during autumn 2020, and the new Alex, which is based on a new 14 by 14 millimeter footprint, will be entering production around September. As you'll also see, the Alex variant is being planned as a new demands are because it moves quickly, this technology. There's new features that come on board, so that will be planned for in sort of late 2021, 2022 as well. One last thing to mention on this slide is the commitment to longevity or a platform or module. Like the footprint, such as SARA covers a common form factor, it gives confidence, we believe, to a designer to invest in a certain range of modules as opposed to a particular module to lay down. The chips are largely industrial parts as opposed to using consumer grade chips, so the life of the product is bound to be longer. So it also allows a designer who has one eye on certification to design with a u-blox module now and have a degree of confidence that it will be available in years to come. For instance, the SARA R410, although we have the new SARA R422 coming out imminently, will continue to be made available through to the end of 2023 at the earliest. So there is a nice long overlap between products coming out and previous generations. So here's a typical summary feature set between the respective SARA R42 and SARA R5s to just give you some indications of the differences. So key features here include improved power amplifier over the standard Qualcomm 9205 reference chipset. So we provide a 23 dBm power output as opposed to 20 dBm in the standard reference design adopted elsewhere. This is important for poor signal environments, typically for IoT applications, down a basement, in a cellar, that sort of thing. As the 3 dBm difference equates to a doubling of RF performance. The SARA R422 range also benefits with that 2G fallback. However, this obviously means that the overall power part of the design will need to be bolstered to cope with that 2 amp spike. For applications that require positioning, there are versions of the SARA R4 and R5 with an integrated GNSS module, which is a u-blox M8 chip. To support the performance of these, there are 2 particular services called Cell Locate and Assist Now. In cell locate mode, if a unit does not have a good view of the sky, then messaging a u-blox server with cell sites it can see will be compared at the server end with an approximate location will then be sent back. The more cell towers identified, the more accurate the position will be. u-blox service garners the experience of 8 million fixes from over 800,000 devices globally over many years. So u-blox have had this service for a while now. This means it's proven, scalable and ready to operate in any position scenario, with the results delivered either to the device or in most instances nowadays, there's a cloud service. So Assist Now provides data in real time via Assist Now online, as well as predicted data via Assist Now offline. And the 2 can either be used alone or in combination. So this boosts the GNSS acquisition performance and lowers power consumption for devices with or without network connectivity. These services are hosted by ThingStream IoT delivery service platform. So for low volume usages, now low volume, they're looking up to 20,000 requests per customer for Assist Now and up to 5,000 requests on Cell Locate. And that's per month. The services are provided free of charge, and there's a modest charge beyond this. Furthermore, u-blox is very mindful of user privacy. So when the position is sent to the Cell Locate server, they're unable to track the SIM used or the device. For further information on the Assist Now Cell Locate, please contact us afterwards. And there's also some features on the SARA R5 particular to that. Some neat features we think are the antenna dynamic tuning, which allows the device to be smarter about the frequency scanning, and that's accessed via the GPIO lines on the SARA R5. It will also be available on the Alex R5 as well. So here's some of the software and security features are best in class, especially on the SARA R5. If you note the integrated secure element, it's a common criteria EAL5 plus certified secure element. So it makes it ideal for government level security or banking applications. As well as these, it can act as an eSIM in a future firmware version, so that no SIM is required external to the module. This obviously benefits because it reduces the BOM cost and the supply chain management complexity with device makers, while still allowing the customers to retain the ability to negotiate tariffs with mobile network operators once you reach the end of your contract with an existing one. So moving on to the LTE power class, u-blox modules have adopted a transmit power of plus 23 dBm across their range of LPWA modules. The rationale behind this is the slightly higher power used in transmission benefits the overall power budget as it reduces the overall time the wireless module is on. This is paramount in instances where signal reception is below average, such as when traveling or in obstructive environments. For example, in buildings, an efficient antenna design also becomes more relevant in these types of environments. So should also be considered at the time of module selection as opposed to later on down the design path. So introducing the Alex R5. In 2019, u-blox announced the production of their own LTE chipset, which was the UBX R5, which provides u-blox with an ownership of the core LTE technology, as opposed to being too reliant on third-party chipsets. Longevity of design is important in industrial applications, and with u-blox producing their own chips, they have control over the life of them. They can also offer longer-term support, and as the development is at a chip level, the level of hardware and software support offered by u-blox through ourselves can become more comprehensive and more integrated. Alex maintains the same simultaneous position in LTE signalling rather than either or, and the overall current consumption is lower in the SIP package than in the SARA modules. Finally, you'll still maintain the additional security options. So this system in package provides all of the same core functionality, the SARA R5, such as the GNSS performance, if it's required of the M8 chip, and it offers the concurrent GNSS and LTE comms, but in a much more integrated 14 by 14 by 1.5 millimeter high or thin package.
Sorry to interrupt, David. You've had quite a few questions come through. Is this a good time to go through them?
Do you mind if we take them at the end? Is that possible?
Yeah, of course. No worries.
Okay, thank you. So here we're looking at the current consumption. It's also very low, and here we show some figures of the SARA R5 and Alex R5 against a Qualcomm MDM 9205 in Nordic NRF 9160 base module in LTE mode. In all scenarios, the Alex is the lowest powered module when using LTE and GNSS, either in cyclic tracking or continuous tracking. This slide is also good at demonstrating the reduction in current consumption when you factor in some of the u-blox low power modes, such as the cyclic tracking mode. I mentioned at the start about the importance of security in many IoT designs, as this is top priority alongside a good radio performance. On security, u-blox teamed up with Kodelsky, who are probably better known for providing a lot of the pay-per-view encryption you get with on-demand TV channels. This has resulted in a commercially hardened root of trust for security functionality and a massively scalable key management system. This service can ensure end-to-end privacy of data, integrity and authenticity, and removes the need for keys or security certificate management. This area also falls under the u-blox security as a service area, which ThingStream will cover in more depth shortly. Okay, so this is my final slide on how to get started. If these products are worth looking at for your particular application, and of course we're on hand to discuss these shortly, then we've got evaluation kits are available now for many of the products. And as I said, some of the modules like the SARA R5 they're in production now. The SARA R42s are coming out in May, and then we're going to have the Alex development environment coming out in around August, with production in November 2021.
I'm Neil Hamilton, so I'm from u-blox. I work with the services division of the company, where we're bringing a number of these IoT services, communications, location security to market. Some of you may be aware we've got a self-service portal, which many of the services I'll be discussing with you today are available. You can just create a domain free of charge and start to prototype and work with some of these if needed. So today I'm going to give you some context around, leading off from what David was talking around, where we are thinking about building devices using low power modules. Then there's the kind of the other consideration when deciding which module, which is where will they work and how do I get the data from my device into the cloud. So if we look at some of the examples David shared with us, this is not an uncommon set of scenarios where we might be designing an animal tracker in the UK for pet tracking, for example, but we might have our manufacturer in Taiwan and the products may be used by customers all around the world. We don't want to limit where we want to sell them. So therefore, if we are choosing a module, we need to find something that will work in the UK when I come to test it. I don't necessarily want to be visiting a lab, just to run diagnostics and testing of that device in the UK, but my partners in Taiwan would also need to be able to test this satisfactorily. And obviously when I sell it, do I limit this to selling in only certain territories, or do I allow the global consumers to buy them? And if it's global, then coming back to the point regarding the modules, well, the R5 module will be limiting you to an NB-IoT or LTE-M network, of which we'll come on to in a moment, but that will be very limiting. So again, this is where we have to start thinking about where the availability of connectivity is for the underlying modules. And this really comes back to the use case of the end customer. Asset tracking, similar thing. We have lots of asset trackers being developed by our customers and partners. Some of them often are running monitoring or tracking and monitoring devices for heavy industries, where some of the plant machinery they're monitoring is in the middle of the Democratic Republic of Congo. Good luck with finding LTE-M coverage there. You'll find 2G and not much else, maybe some LTE in Kinshasa or some of the city areas. So these are really serious considerations, and it goes on for everything. And so during your development process, you have to think about, when scoping the module, always try to consider the end customer, footprint of where they will operate. And if we take a slightly closer look at the world of low power connectivity and where this is available, this is the current GSMA low power wide area network map, and it's very positive in terms of showing coverage availability. The URL is at the bottom of here, and you can find it online, but when we distribute the other slides, you can visit and look at specific countries. And when you look at specific countries, you'll often see that the whole country might be coloured blue to say that there's NB-IoT only available in that country. But then when you read the details, you'll see that it's in a lab only in MTC in Saudi Arabia. So there's no actual coverage as such. So again, this is an emerging market. It's not to say that the low power wide area networks, aren't suitable at all. They completely are. They're just taking time to roll out. So again, for design-ins that are occurring late this year into next year, and that the products are going to be rolling out in Europe for LTE-M, there should be high confidence. We see more and more support, especially in roaming. So one of the u-blox offerings now includes a SIM card, which we'll come on to, which provides ultra low power connectivity or ultra low power communications between, a device and the cloud. And again, just like, we're acting effectively as an MVNO with that card, as are many other providers in the world. And the whole industry is facing this slow challenge of seeing the commercially supported roaming of LTE-M on existing roaming agreements. So today, with our card, our SIM card, obviously it can roam in maybe 190 countries across multiple networks in each country. And that's today for 2G, 3G, LTE, and now LTE-M is starting to light up because the industry is starting to move forward with inter-roaming agreements. NB-IoT, however, isn't yet reflected in the same way. It is very much a domestic offering. So if you're working with a project where you're developing parking meters that are going to be put into the ground, maybe in underground car parks, as David alluded to, and they're not going anywhere, they're fixed in position. And if you need low power wide area, NB-IoT with a local partner SIM card could well be the right answer. So these are the considerations we have to think about. If we want a truly global product, then there's other things we might want to consider. In regarding 2G as well, there is some countries, as you may have read about or may be aware, have turned off 2G. They've repurposed the spectrum. Japan, Korea, Australia, and a few others as well. In the USA, we expect their sunset. T-Mobile was the last operator there, I think, offering 2G now. We're expecting to see that sunset December 2022. But when it comes back to global products, and we need, there needs to be some considerations around that 2G fallback will be falling back for some time. And in many cases today, oddly, if we're using a modem with LTE-M and 2G, you'll quite often, and we certainly see from our systems, 2G is the norm and LTE-M is the fallback because it's not commonly available in all the territories where these products work. Container tracking and that kind of supply chain applications is very common there. And 2G itself, in many countries is going nowhere fast. I know we have some countries announcing when they intend, but if we look at some of the applications such as in Africa and in South America, the majority of payment systems for everyday money transfer are all based on 2G. It's secure and it's used for banking. It's the primary source of maintaining peer-to-peer money sharing and payments for things like PayPal. So that in certain territories, you shouldn't just, or I guess the message here is, don't think 2G is dead right now. It could be 10, 15 years, especially when we also consider things like the EU eCall service that's embedded in all the cars we drive. Again, the original standards have dictated this has to, well, it doesn't have to be, but it was 2G was adopted. So when we have cars in the European Union and they crash, they automatically call emergency services based on this eCall system. And today it uses 2G and cars last for 5 to 10 years. So again, there's some ramifications around how 2G is perceived. And again, as a fallback, I think it's great. So thinking about, once you've got applications that roam, the R422 that David mentioned with the 2G fallback is a solid product for kind of giving you some longevity, but also reality, giving you coverage today using the 2G component. But from a global application approach, then Cat 1 is also an option. And oddly, in the u-blox portfolio, it isn't a module we'd naturally include in what we call the low power portfolio of products, because it's not. But when we start looking at the rest of the application we're designing, well, actually, the modem power is only one part of the considerations around saving, preserving battery power. And it is possible effectively to maybe use a Cat 1 module. Yes, it's more expensive, but by paying an extra $5, $10 for Cat 1, and then if you can get the device to behave in a long life, low power mode, suddenly you've got the insurance of having a product that can ultimately work anywhere in the world. And that's exactly what we're doing with our offering. The challenges around power, everything affects power. And it's kind of, I know many design houses we've spoken with are just constantly fighting how to reduce power. And that's exactly where u-blox is headed with our modems and our services. It's all focused around preserving that power when it comes to building these independent devices when they don't have a power source. And so the whole use case, if we look at what we're trying to do, what that device is ultimately trying to do, we have effectively here in the simple diagram, a tracker, a low power tracking device we have on the left-hand side. And then we have, as a designer, we've got to think about everything else that's going to happen. We need to make sure that the device software is fully optimized. We're using a protocol that's lightweight. It's not going to keep the radio on for long, and we can dispatch the data into the cloud quickly. As we just spoke about, it needs to be able to efficiently connect to networks. Again, considerations of SIMs is really important, because if you use some SIMs from certain carriers and they roam, they will steer onto specific networks. So even though you might be sitting next to or the device might be sitting next to a cell tower that's a Telefonica cell tower, and maybe I'm a Vodafone SIM or a Vodafone partner SIM, I will reach out and try to find the Vodafone partner tower, which could be 2 kilometers away, because my business rules say data's expensive from Telefonica, so don't use this cell tower. But if you could remove that and mitigate that problem and just hop onto any cell tower, now we've improved the power capabilities of the device. And that's exactly what part of the offering here is providing. And it goes on, the bearer types, the roaming, and then more importantly, once you've got the data into the cloud, organizing it, well, now we can turn our device off, or maybe we just get our device to do as little as possible and allow the cloud to do all the manipulation of the data and the preparation of it for the upstream application. So that takes us into the world of kind of what protocols do we choose? Naturally, many designers we work with often haven't really considered some of the more modern options. MQTT-SN is now growing in popularity. MQTT is by far the most popularly used IoT protocol. And of course, if we're working with maybe closely with our carrier partners, we might be thinking about using lightweight M2M for device management. And again, as you can see here, that's kind of leveraging CoAP over UDP. But as we look at these different types, naturally on the right-hand side, we're showing here something called ThingStream, which is what u-blox is offering. We have our own SIM, we have our own SDK, and that is now being built into or using the native MQTT-SN capabilities of the new modules that are coming. And this is super efficient in the way it manages data. So again, coming back to it's not just about the modem that's burning your battery, it's the time on air it spends and the amount of data it has to send whilst doing that. And so we see the things that are typically TCP/IP based, certainly HTTP is inefficient, I think we all recognize this, but regular MQTT and CoAP, they both need to be secured. And once we start having to put in certification and managing security policies, in addition to the larger headers and all the information that comes along with that protocol, the payloads get big and our time on air is getting longer. And so MQTT-SN is super efficient in the way it enables all of this to work. In conjunction with our SIM, which is operating inside a private network, security is kind of baked in as well. So it's a really efficient way of now enabling our devices to live for a long period of time. Another aspect of this is positioning. In many tracking applications, the tracker itself, the device itself doesn't necessarily need to know where it is, but the enterprise does. They need to know where that refrigerated, COVID medicine is within maybe 10 meters of accuracy at any given point in the day. And so that we've got really clever and efficient ways of doing this as well. So again, using some of the modules we have, the built-in GNSS, it's possible to allow the ability for the receiver to scan the sky, maybe grab 3 to 5 seconds, a snapshot of GNSS information, and then publish that using MQTT or MQTT-SN into the cloud, and then power off the device. We don't need to spend tens of seconds, maybe even minutes, looking for 3-4 satellites to get a position, because the device doesn't care. We just need a snapshot of information to power off the device, get it into the cloud, and then using, as many of you may know, u-blox's heritage has been in around GNSS technology. So now we have, cloud-side information systems that can predict and understand where things are up within 5-10 meters based on those snapshots. So again, we're radically reducing the amount of power needed, both for the modem being on air and also the receivers, the GNSS receivers, being scanning the sky as well. So the offering we're talking around here, and we can go into more detail directly with the team at Alpha Micro, but effectively, yes, it's a SIM, but the SIM unlocks this unusual service in terms of it's not a regular data service. What's happening here is the device is fundamentally making a radio connection to the network. It's then using MQTT-SN over UDP in really efficient bursts to get key information into the cloud and enable you to power down your device. And there's some more involved as well. This is typically the architecture, and again, I don't look to dwell on this for too long on the call on this webinar, but effectively you've got messages coming into our gateway, but then they're coming into what David mentioned earlier, the ThingStream service delivery platform. And now we're doing even more for your customer solution, the overall solution, because it's not just about getting data into some web servers. We have this thing here, a product called the Data Flow Manager. And this enables you to take those messages. So you've got your MQTT messages or SN messages coming into the broker, and now we can apply logic. We can prepare the data for upstream usage. And so we have these, what looks very much like Node-RED. It is basically Node-RED, but we've kind of rewritten it in Java, and it runs at scale. So now it's usable across tens of thousands of devices. But it's a really powerful environment to quickly build my data flow and get the data into the cloud. So again, all of this is part of the same service. So we're now reducing the number of stakeholders and people and technologies we need in order to get the data simply from the device and into that system. And there's a range of pre-built connectors for upstream systems. And what's really interesting here and what we're seeing is the industry is very much in the proof of concept. There's lots of companies playing around with IoT, and they're building their their prototype systems. And this platform's great for prototyping, but what we're seeing now are more and more enterprises now starting to scale and now moving to 5,000-10,000 devices. And now in these larger organizations, the data needs to be received through the official kind of data portal within these organizations. And many of them deployed enterprise message buses. So the likes of TIBCO, IBM, Software AG, these are the gatekeepers to any data coming in from the internet into these organizations. And again, the system here is built ready for scale and production, as being also equally as flexible and powerful for prototyping. So what we're offering here effectively is the u-blox with our portfolio of services. We've touched on two here, the SIM-based low power global connectivity offering with all of the extra, taking away all of the issues that typically our customers face when it comes to choosing which carrier, etc. That's all removed from the overall customer problem. We can take care of all that. And then our application partners can just focus on building the application, the right device, the right firmware, and then we can get the data from that device into the cloud, all as one solution. And the really interesting part, and again, this is something we can touch on in more detail, is the way we commercially offer this. And I think it's really worth highlighting this. Whereas before, each of these vertical columns are really highlighting things people have to consider when building an IoT solution. So yes, the bytes, the line rental, the roaming fees, the SIM management, those four items are typically what you'd have to pay a carrier for or work with an MVNO to resolve how much all of this is going to cost you. And it would be based on a contract term. In addition, you would have to figure out the security aspect, what you'd need to do there, how you process the data and get the data into an upstream system. As you can see from the bottom, the ThingStream platform has a service called MQTT Anywhere provided within it, and that takes care of everything. And from as little as 25 cents per month to get data from anywhere in the world into the cloud, fixed price. That is compelling, and we find that in conjunction with the technology is really picking up interest and momentum in people who are trying to get prototypes to market quickly. It's also provided in the pay-as-you-go format. So again, there's no obligatory 24-month contracts with a $1,500 upfront fee just to get going with NB-IoT. Far from that. We recognize that IoT starts and stops and iterates, and again, our commercial models are designed to mirror that as well. So that's my update, if you will, of the considerations around the low power aspect. Isn't always about just the modem, it's the use of a protocol as well, and what you want your application and solution to provide. And we think that's really interesting. And our partners, Alpha Micro now, are in a position to help you understand more around that side of things as well.
From the sounds of the questions, you worked on the audience have by and large worked on embedded wireless designs before, so you'll see that getting the antenna to operate with the module and achieving close to the published performance specs for the module can be challenging, and as such they're often asked about during technical support calls that we get. As such, it is a frequent topic for the guys when assisting in optimization of the antennas for an application. In 2012, we launched our own range of antennas which meet the technical specifications and fully support the modules that we supply. So we actually work very closely with companies specialising in IoT antennas. There's about 4 of them, both in Europe and China, such as 2J antennas, which many of you would have heard of. And as such, because they specialise in IoT, M2M type applications, they're much more on our wavelength, pardon the pun, when offering antenna solutions. So this is reflected in the service that they offer, not only in delivery of the final product, but the support they offer during development. So if you take a worst case look at a type of internal antennas required in a solution, think of maybe a parcel tracker or something like that. It would be reasonable that half of these radios can be in a small enclosure. The recommended distances between the antennas and then consideration if ground planes are required, this can throw up some challenges affecting performance, and obviously compromises are going to be inevitable as a result. So integrated antennas are usual in tracking devices being covered today by our slides generally. And so they'll typically have embedded antennas such as the flexi strip antenna you see top left, ceramic patches in the case of the GNSS one on the bottom left, and PIFA designs which are bottom center. So traditionally these PIFAs or planar inverted F antennas have been constructed using ceramic, but more recently fiberglass antennas have become popular, mainly due to price. To put some perspective around this, we're probably looking at around half the cost of a ceramic equivalent. Another area to look at on the PIFAs are the frequency coverage and the VSWR, which I'll come on to later. Bear in mind that you may not require an antenna to be absolutely top-notch at all 4G frequencies in the case of LTE-M or NB-IoT. For instance, if you are just deploying in the UK market and you don't have much chance of roaming, then having an antenna working well on 800 or 900 megahertz may well do the job and be more price effective than trying to find one that covers the breadth of 4G frequencies. There are obviously external alternatives which offer multiple omnidirectional technologies, and a good example of that would be the top center glass or dashboard mount antennas. So you've there got GPS, you've got LTE, you've got short range communications in there, for instance. Okay, so when selecting antennas, you'll find many manufacturers produce data sheets which only consist of 2 pages and are scarce on detail. You'll often find this as the antennas may have been simply cut to length with no serious testing to the final product, which results in a poor performance. So we critique our antenna suppliers and the key metrics to consider. So first, looking at return loss. So the measurement and control of gain and reflected power in wireless transmitters are critical auxiliary functions that are often overlooked. The power reflected back from an antenna is specified using either the voltage standing wave ratio, VSWR, or the reflection coefficient, also referred to as return loss. Poor VSWR can cause shadowing in the TV broadcast system as the signal reflects off the antenna reflects the gain off the power amplifier and is then rebroadcast. In wireless communication systems, like what we're discussing, shadowing will produce multipath-like phenomena. While poor VSWR can degrade transmission quality, the catastrophic VSWR that results from damage to coaxial cable or to an antenna can, at the worst, degrade the module over time, eventually destroying the transmitter, which is obviously not good for long life applications. If you're looking at peak gain, look for a chart recorded from an analyzer, and it will demonstrate the true performance across your target frequencies. What you do find in some data sheets is just a peak gain at one frequency, which is simply referenced as a bullet line item, which is quite common actually, but it's a very misleading way of reporting the performance. You then look at the bottom left, average gain. The more efficient your antenna at a given frequency is, the better it will perform. It may seem obvious, but a poorly designed antenna will be very efficient at delivering performance, such as a long time to acquire a network or GNSS constellation, and that will have an overall negative impact on the battery life of a product. And lastly, the radiation pattern. It shows how the antenna radiates the signal into space or receives it. For omnidirectional antennas, such as the 2.4 gigahertz ones shown, in the vertical plane, you want to see almost a full circular radiation pattern, demonstrating the signal can radiate a full 360 degrees. So our typical data sheets that are supplied with our antennas are at least 5 pages long and demonstrate all of this data in an informative way. We're always available to have a chat about your requirements, so please feel free to contact us or visit our website if you have any questions.
Okay, I'm Nick. I'm just going to go through a few of our the power products for IoT, and basically we're just going to go through batteries today and the sort of battery technology that you use in separate applications, because I've seen a few questions come through. So the things that you have to consider about batteries basically are the capacity, how long you want the battery to work, whether you want them to be rechargeable, do you want them to run for years between replacements? So do you need a battery that will last the entire life of the product? And there's so many other things to consider. You've got temperature, dimensions, vibration environment, the stability over time, and the life of the battery, the voltage. So there's too many things really to just put in a simple overview. At Alpha Micro, we use one major supplier. We use a company called Bondrex. Yes, they're Chinese. Where virtually all batteries come from nowadays. But Bondrex actually supply many of the tier 1 battery manufacturers that you hear of in Europe. So you may think you're buying European batteries, and you're probably buying Bondrex in a lot of cases. Historically, our customers use lithium-based batteries. They're 3.6 to 3.7 volts. They're well suited to RF applications and RF modules across the range. So I'll just talk about basically the 3 types of polymer lithium batteries we cover, which are lithium polymer, the lithium thionyl chloride, and lithium manganese, which are general types of battery that cover all the different currents and voltages and power ranges, and some supercapacitors I'll throw in as well, just to confuse and show you where we use them. So first, I'm looking at the lithium polys. They generally are nominally 3.7 volts, but on charge they can go up to 4.2. They float about 4.1, and they can fall to 3.6, 3.5, which is well suited for u-blox modules. There's a surprise. They have pretty low internal impedance, so they're very good for running transmitter stages that might need high power. We have a range already of batteries, standard products that range from 40 milliampere hours up to 10 ampere hour life, which is quite a large area to cover. And if you need more, you can multiply them up parallel, serial, depending on whether you want more voltage or more current or capacity over time. They're well suited for GSM, specifically 2G, because of the large pulse currents they can supply. But you do need protection circuits on lithium batteries. You wouldn't want to short out the cell itself. So if you look at the diagram or the photograph on the left of the slide, you can see the batteries themselves have areas to the left of the cells in these cases, where hidden under the plastic coating is a protection circuit. So if you short the battery, it's protected. If you try to overcharge it, it's protected. If you put too many volts in it, it's protected. So the lithium cell itself doesn't suffer any damage. So to use these, you still need a charge circuit. You can't just stick volts across them and charge them. So there will be circuitry that you need to follow, if you like, for putting current into the batteries, and you need to measure and follow, look out for the temperature of the batteries. Typically they will cover 0 to 40 degrees. You can charge through that range, and you can discharge them slightly outside that range at various handicap currents, slightly lower at the extremities. We have obviously experience in all charging discharge curves of these batteries and can help anyone who has any issues. They tend to have a non-linear discharge curve for voltage. It's not a nice straight line from fully charged to flat. There tends to be an initial, and those of you who use these batteries will know, there tends to be an initial drop very fast on the voltage. It'll then slowly degrade on a nice smooth curve over time and then fall off a cliff at the end. So by looking at the battery voltage is not a good way of deciding whether these batteries are full or empty. You tend to need something like a Coulomb counter, which counts the amount of charge going in and out of the battery at any point, or the Americans call them gas gauges, so you can look for either of those online to find. We've got experience with a few, and I know the foibles of quite a few, and if anyone wants help with those, I can help through the team. The batteries are particularly useful, as you can see on these slides here, for asset trackers, for things that you wear, applications where charging the device is an option, and where the battery is easy to get to and you can easily get to the device. The batteries we can supply, we've got many bespoke types of wiring. There's 2 or 3 wire batteries. You can have the temperature sensors in the battery or on your circuit board. The Coulomb counter can be on the battery or on your board. You can have thermistors only on the battery, and obviously the size of the battery can be more or less whatever you like it to be outside the standard devices that we have. Obviously they're ideal for GSM. There's a large coverage network for GSM, so they're pretty good for the applications such as vehicle tracking, pet tracking, e-scooter tracking, and tracking. tracking, really. So moving on to the second type of battery. For those of you who are still awake, it's not long, trust me. The lithium thionyl chloride batteries, they tend to be 3.6 volts nominal. Very high volume capacity for the volume density of the battery itself. The disadvantage is they're quite high internal impedance relatively, so you can't take pulse currents out of them. A very long shelf life, many years, greater than 10 years, and they're suitable certainly where battery swapping is a chore, where the device is in a difficult to get area, or somewhere out in the middle of a field somewhere where you don't want to be able to get at it often. And they're very suitable on their own, will perfectly happily drive LoRa, Sigfox, Zigbee, Bluetooth type applications. They will be no good for high pulse currents. So in those cases, you'll need to use something like the lithium hybrid capacitor that we're showing at the bottom of the slide as a supercapacitor, which charges from the battery and just fills those gaps when you need a pulse current for something like LTE, Wi-Fi, or GSM, and then you can fall back to standard battery after that. By not drawing large currents from the battery, you keep the battery cool, and obviously heat is power loss, so you wouldn't want to do that, hence the supercapacitor fills the gap. Typically a D-size cell of thionyl chloride battery can have anything up to 19 ampere hours of capacity, which is enormous compared to the other batteries we talk about. And if you had a device that was drawing a milliamp out of that average, that'll easily give you over 2 years of life. So less current, more lifespan, if you like, for your batteries. So they're ideal for battery backups. And for Apple and PC motherboards use them. Just a half AA size cell will keep your clock and your battery backup going for more than 5 years, quite easily. And they're particularly useful for things like ephemeris backup on GPS modules. So once you've gone through the effort of downloading the ephemeris on your module, When you power it down, you don't want to lose that and have to pay in current to get it back again. You might as well keep it. So good for remote systems, typically used for water monitors, for leak monitoring, for sewage monitoring, anything out in the field somewhere. Gas monitoring where there's no mains around and you wouldn't want mains close to gas. And anywhere where there's really no mains power at all. Lithium thionyl chloride, very good, long life. Nearly there, honestly. The last type I'll mention, lithium manganese dioxide, 3-volt batteries, another thing that you see on motherboards as well. Extremely small size, high capacity for their volume, and very high, quite high internal impedance. Not as bad as lithium thionyl chloride, but you wouldn't want to draw big currents out of them. You wouldn't because they're small anyway. They're very good for low power, long life applications. The things you can see here are, I mean, they're the sort of batteries you find in your watch, which doesn't draw much current, and they can be extremely tiny in that case. They're good for tire pressure monitors, as you can see, middle top on the slide, for room thermostats and for valve actuators. If you have no space, not too brilliant for valve actuators, but they can substitute multiple standard AA batteries in that sort of application. And also consumers understand these. If you're in a consumer product, people understand the C2330 type battery and they know what that means. They'll turn up in your car alarm blips and that sort of stuff. So for replacements later, they're easily available. And you have products with that in, then they can be easily serviced. That's really all I will say. And thank you for your time listening.
I will just show you this final slide, if that's okay. We've recently been engaged with this company called Epishine, who are based over in Sweden, and they recently launched their brand new flexible organic printed light energy harvesting cells. And as you can see for the picture, they're very flexible, can be integrated into IoT type products. They've been optimized to harvest the energy from indoor lighting, so very specifically indoor lighting, so very low power type applications. They're quite a new company. They've been around probably for only about 2 or 3 years, mainly doing all the research and development. But if anybody is interested in this, please let me know, drop me a line, maxine@alphamicro.net, and we can certainly talk to you about any potential projects that you might have where you think that this would be a good thing. It's certainly a green option moving forward, I think.